In our second video on exponents, we're going to be mathematicians and we are going to discover our shortcuts. But please remember, if you can't remember the shortcut, no problem. Shortcut implies there's a long way, so you just go the long way. Okay, so this is the first part. We're only going to do one shortcut in this video, so let's get started on that. We all know what 3 to the 5th means. We've seen that several times today. It means the instruction says take 3 and multiply it times itself 5 times. So I'm following my instructions there and multiplying that 3 times itself 5 times. 3 squared, okay, that 2, the exponent 2 applies to the 3, and the instruction says take that base and multiply it times itself twice. So we already know that. So let's take a look. If we multiply 3 to the 5th times 3 squared, we go, well, I don't know how to do that. Yeah, you do, because you know what 3 to the 5th is. That is 3 times 3 times 3 times 3 times 3. There's 3 to the 5th. And you know what 3 squared is? 3 times 3. There's this 3 squared. So now we've got 7 3's being multiplied. 3 times itself 7 times. What's the shorthand for that? 3 to the 7th. So keep that in mind. I'm going to erase, or let's just put it up here. We have discovered that 3 to the let me do this in a different color to keep it sticking out a little bit. We have found that 3 to the 5th times 3 squared equals 3 to the 7th. We found that on our own. Okay, next one right here. X to the 4th times x to the 8th. Well, we know what that means. X to the 4th, x times itself 4 times, x to the 8th. 1, 2, 3, 4, 5, 6, 7, 8. So there is x to the 4th times x to the 8th. And what do we have? We have 12 x's being multiplied, and we know the shorthand way to write that is x to the 12th. So in blue, let's keep track of what we're discovering here. X to the 4th times x to the 8th equals x to the 12th. Okay, in this one, with all of these y's. Okay, now what we're going to do this time is, okay, I'll go ahead and do all the y's. So we'll see what this looks like. So we've got y to the 5th, 1, 2, 3, 4, 5 y's being multiplied, times y squared, 2 y's being multiplied, and all of these are multiplied. So let me try to sneak some dots in there to indicate multiply. There's y squared, y cubed, 1, 2, 3, and then finally just that little y at the very end. And what do we have? We've got all of those y's being multiplied, but how many do we have? It looks like we have 11. So the short way to write that is y to the 11th. So let me create some room so that we've got some space to remember what we've discovered. And see if we can find our shortcut. I think you probably already are there, but you're a little bit faster than I am. So we've also got y to the 5th times y squared times y cubed times y, and we ended up with y to the 11th. Okay, so what does it look like is happening? One thing I want to point out is, do you notice that our bases are always the same in these problems? Okay, so I'm going to keep mentioning that. When the bases are the same, that's when we're going to have a shortcut. So in the first one, 3 to the 5th times 3 squared gives us 3. So take a look at this. We have common bases, same base, 3, and the answer, our base stays the same. Isn't that sweet? Okay. Then, how do we get our exponent? Well, 5 plus 2 gives us 7. Base is x, answer, the base is x. Exponents, 4 plus 8 gives us 12. Oh, how are we getting this shortcut? In the last one, I'm a little bit confused here, because I verify that all we have are y's. But when I add up those exponents, 5 plus 2 plus 3, I get 10. So how did we get y to the 11th? Okay, there's an invisible exponent there. It may help you sometimes to put that 1 there to remind you when you don't see an exponent, there's an implied 1. Okay, let's summarize what we just learned there. So what we found is when you are actually, and then in yellow I'm going to fill in the blank, when you are actually multiplying, the shortcut is to do what with the exponents? Add the exponents. Okay, so when you're actually multiplying, the shortcut is add the exponents. And can I remind you, this is when bases are the same. All right. Okay, one thing before we leave this is that, let me see if I can insert a page here to point something out. Insert new page. All right. If you do, let's take a look at another problem. When you have, for example, 3 to the 5th. I'm in love with 3 to the 5th today. Times 2 to the 4th. Okay, now, when I ask my students to guess what they think that answer might be, most of them say 6 to the 9th. That seems reasonable, but let's make sure and decide if that's actually the case. And some even say 6 to the 20th, and I don't know what other answers I get. But we can figure this out because we're mathematicians, and we can determine what the correct answer is by just reverting back to what we know exponents mean. So 3 to the 5th, so I can say for sure 3 to the 5th is equal to 3 times 3 times 3 times 3 times 3, and 2 to the 4th is 2 times itself 4 times. All right, so can we do anything to simplify that? Well, you're saying, well, you can take that 3 being multiplied times itself 5 times and write that as 3 to the 5th. And you can take that 2 being multiplied times itself 4 times and write that as 2 to the 4th. Remind you, there's where we started, there's where we ended. So, these shortcuts, so I'm going, well, nothing really happened very exciting there, right? These shortcuts that we're looking at in these first 2 shortcuts are only when the base, cats are fighting beside me, so I'm messing up here, when the bases are the same. If they're not, well, I can't tell you anything about that. Okay, we'll keep going and get our second shortcut in the next video.